Okay, so everyone, thanks for joining us today. My name's Lai. I'm the director of Measurement Lab at Code for Science and Society. Today, we're doing a town hall about our plan to stop collecting IP addresses. The larger conversation, though, is around privacy and research usability. So wanting to check with you all, our community, and our users about how this plan will affect your research and collect feedback. So that's the lens that we're coming at from today. So Matt's going to present and then we'll have a discussion afterwards. And the reason we're recording is if in case folks can't attend today, then we're going to send this recording out and ask for feedback from them as well. So if there's any questions along the way, please feel free to just add in the chat, but we'll also get to them later. And with that, Matt?
Okay, let me do a sound check here because we haven't done sound check. It works.
Yeah, we can hear you.
Yes, there's several ways in which I'm not running the setup I was expecting to be running, so we'll see how this goes. Whoops. So yes, I wanted to talk about what we want to talk about today, sort of the same story that Lai gave, but a slightly different spin. MLab fundamentally has to balance the tension between privacy and good, easily analyzed data. And this is sort of a fundamental problem. But what I want to have today is a conversation about some of the aspects of that. I don't actually I'm not in this presentation proposing a complete solution. I'm actually talking about all the different pieces of the solution and all the different degrees of freedom that we have, and try to, at some point, make a design out of it. So I'm going to talk about the problem statement, which is there's actually some subtlety to it, and then review the current platform. Lai, your microphone's open, I think. Somebody's microphone's open. Review the current platform, and then sort of inventories of things that we might do. I think of it as a tinker toy of parts we might use, some of the things that might go wrong, and considering how it might impact people's research. There's actually a lot of opportunity to make some research that we can't do today possible. So first of all, our privacy statement. We have, since the very beginning, collected and published data by IP addresses. It was our original intent, in fact, that you could access our data anonymously on BigQuery. When MLab started, BigQuery allowed that mode. As BigQuery has grown up and become a production product, you can no longer access BigQuery without a Google account, but in the early days you could. So there's been some changes over time, but the key issue is, at the end of the day, what will happen from this conversation is we will be making a change to the policy statement, the privacy and statement. And we want to be cognizant of the fact that what we do has to be reviewed and understood by lawyers at some point. And that becomes a very strong forcing function. We do need information about repeated tests. There's this astonishing statistic. This is the cumulative tests by IP address. Started out by sorting the host by how many tests each one ran. And I think the most astonishing number of this, they're all kind of mind-boggling to me, but 10% of the clients contributed almost 60% of the tests. Just an astonishing amount of data, and we need to do something to debias the data from this effect. So we need to strike a balance, and that basically is going to happen by doing some form of adding additional information and removing some address bits, removing some identity from it. And I actually welcome thoughts. I actually welcome people to raise their hand, although I may or may not notice them. Some weakly related secondary problems. I mention these because they intersect. They mostly overlap through the issue that they have to do with how we use and assign IP addresses. And if we're making changes there, we might actually consider about whether or not we can address these problems. These are sort of out of scope for today's presentation, but they're worth mentioning. There are some places where IP addresses are so scarce that everybody is natted to the first approximation. All consumer grade connections are natted, and we can't get 64 contiguous IP addresses, which was what we need for a server pod. And so we're currently, with our current platform, locked out of even deploying in those areas. So that's one problem. Another problem is that for certain kinds of measurements, like measuring cell phones, anything that attracts, what you really care about in terms of the infrastructure, the topology, is what tower is somebody using. And anything that tracks the association of phones to towers turns out to leak not just PII, but actually dangerous PII that people don't want leaked. And this is something that we've often, we ought to get into measurement space or mobile space better. And there might be a solution to that lurking in this presentation. So the current platform, I'm going to go over this real quickly. There's actually more detail in the next two slides. I'm not going to talk about the next two slides, but I'm going to talk about this one. A user makes a request. The locate service chooses a server. We're currently running 550, 560 or so production servers globally. That test, the user connects to NDT, and NDT does a measurement. And associated with NDT, there's a whole bunch of sidecar services. UUIDs assigns a unique identifier to every single test. We get TCP state information. It's every 10 milliseconds in the raw data. It's every 100 milliseconds in the parse data. We do actually a scamper MDA traceroute back to the client. We get full PCAP files for essentially every test. And there's this thing called the annotator, which collects metadata. All this information is pushed into the GCS archive where it is published. And then we have this thing we call the pipeline, which parses all the data and joins it together and publishes it to BigQuery. And an important detail here is we have this thing called Gardener, which reprocesses all the data periodically. And traditionally, it's been 12 years worth of historical data roughly every 6 months, and the most recent couple of years of data every 2 to 6 weeks, depending on what we're doing. And the power of Gardener is we can make changes to the parser and the pipeline as we get better insights and understanding into the data, or as we change our policy about what we're publishing. And so with Gardener, we can retroactively, or we can update how the data is viewed for everybody, for how historical data was viewed and how new data is viewed. So this is the same stuff in more slides. Let's see if I said anything, didn't say anything. Yeah, annotator collects a bunch of data. I'll talk about that later. So the general strategy is add more information in the annotator and then redact IP addresses. And there's a lot of choices for both of these. And most of the talk is actually talking about the choices and the implications of those choices. And there's also an important question, which is where in the process do we do the redacting? Annotations, we're already collecting route views in MaxMind. These are two external public databases which tell us something about the IP address and how it's being used. There's lots of ways, and one of the things we were almost certainly going to be adding is some sort of way of adding a hash, a key, an obfuscated IP address to the data, and there's a bunch of ways of doing that. And then we also have occasionally used TCP fingerprinting to help us, for instance, to detect clients that are sharing IP addresses. We don't do this in a formal way. The information necessary to do that appears in TCP info, and so you can do it in a query. And it's not supported directly by the platform, but you can do research queries that do that. It just came to my attention as part of preparing this talk that in fact the TLS negotiation that appears in clear text and is fully fingerprintable. And what that tells you is the version of the browser that somebody is running. There are a few thousand fingerprints out in the wild, so it's not particularly specific. Although I've occasionally, in the old data, in the old Web 100 data, somebody was using a completely custom build and they had a version string I've never seen before. So there's some user in the old Web 100 data years ago that turned out to sort of be accidentally completely unique. So we could consider doing this. It's currently, this information is not even collected. We don't know anything about what's there. So the hashes do most of what we want to do. And one of the ways of extending it is to have multiple keys and use different keys and actually have multiple hashes and rotate the keys on a different schedule. And what this would let you do is connect IP addresses together across key changes. And you could build sets over possibly periods of years, even if you chose to change the keys every couple of months. It's also possible, we have the plumbing, it's actually in production now, to feed annotations through from the clients. Very few clients use this. A few clients send things like their major version through the pipeline. People have occasionally wished for a strong client UUID. This, of course, has worse privacy implications than even IP addresses. It's not seriously under consideration, but I wanted to mention it for completeness, that we could do this. We're also experimenting with doing actually geohash of HTML5 location. I don't know how much you've played with HTML5 location, but many applications know where my laptop is within a couple of feet. It's kind of astonishing how accurate that is. And we could do our own fuzzing. The problem is this has to be done on the client in order for it to be adequately protected. Or we need to change a lot of other things, maybe do it. Where do we do the redacting? Well, I mentioned earlier, if you redact in the fleet, you can make changes. You can change your mind later. You have a lot of opportunity to make improvements. We can do all sorts of cool stuff down the road, but it doesn't really, excuse me, I'm sorry. I'm saying it backwards. Redacting IP addresses in the fleet provides strong protection in the sense that you can't ever recover the data. You can't ever de-anonymize the data unless there are bugs, leaks. But you need to do the annotation at the same time, and you're exposed to the weaknesses, any weakness in the annotation service. You can't fix it later. Boy, it's early for me. A initial route will be doing the redaction in the parser in the ETL pipeline. We don't forfeit anything. We can make changes. We can change it. We can do all sorts of things in it and change your mind and do it again later. I can pretty much guarantee that whatever we do, if we decide to do it in the fleet in the future, we will start out by prototyping it in the parser, which will give us an opportunity to understand whether or not we're making any mistakes. I can also imagine some situations where some sort of hybrid solution ends up being the long term. We redact the information in different ways in different places for different reasons, or we have a single stream from the fleet to the parser, which is not redacted, and everything else is redacted. Another thing that we don't do, which we could do, is add acceptable use agreements. This has become common. I think everybody else has one. We don't. We took the point of view that open is open, and when the platform was originally built, you could in fact access our data. You could access BigQuery anonymously. Did not need to be logged in anywhere. Can't do that anymore. But we can change this, and we can put in language, and there's a lot of acceptable use agreements in there that often include things like prohibitions on specifically trying to reverse engineer or de-anonymize the data, and restrictions on publishing and all that kind of stuff. However, none of these solutions change the collect and archive IP addresses, a part of the NDA, and that is the piece that many consumers of our data have trouble with, or many organizations would like to partner with us. Another thing that's come up, it hasn't been announced yet, but we're experimenting with serving from the cloud. And as part of that exercise, we realized that the cloud edge actually does a server-side NAT. And this is a technology we hadn't considered. And the kernels that we use, the Linux that we use, in fact, has built into it all the plumbing to do a completely general NAT. Rewrite all 4 fields of connection 4 tuple. It's in the kernel, it's in our code base right now. We don't know how to use it. We don't know if traceroute works through it. We don't know, there's a whole lot of things we don't know about it. I can imagine doing something like this further down the road. I can't imagine doing it in the near term because there's too many things that we don't understand about it. My forward-looking engineer is going to want to say that as we deal with serving in the cloud, we will want to make sure that the solutions that we use there for dealing with the fact that the cloud has to NAT, in fact, are in some ways extensible and could, in fact, address this case as well. Because this is super powerful. It's essentially, it's redacting on the fleet, except the NAT information completely is capable of being used to completely reverse that. So you have a single channel which exposes all of the information. So one of my worries about all of this stuff is there's some ways in which there might be IP addresses embedded in places that we don't know about. My sort of favorite pathological example is if you do a trace route and the trace route goes through a tunnel and it actually works through the tunnel, which is often not the case, there are potentially 3 or 4 different protocol layers in the reply message which have IP addresses in it. And you don't know which of those might be sensitive and which of them are not. This is because the tunnel has 2 sets of IP addresses inside of the ICMP error message, which is doing the trace route. There are other things like somebody pointed out to me when I was working on an earlier version of this talk, that in fact PCAPs leak IP addresses too, unless you can, if you can infer the server's address, because you have to fix the checksum, or you have to know what the checksum is. Traceroute. The other thing is traceroute itself is problematic because the last hop, you don't know which hop is the last hop until you get there, or it's close to the last hop, and there's a chance that the infrastructure addresses that are in fact fingerprintable relative to what the host is. And I don't understand this part of the problem at all, actually, to be perfectly fair. I was recently told that there's some researchers that are using our data because we don't redact IP addresses, that all other data, all other public traceroute, large traceroute data sets with redacted IP addresses are not useful for the particular research questions they're trying to ask. There's some IPv4 things to be aware of. There, an early version of this work, which was done perhaps 12 years ago, 10 years ago, it was done in 2012, there were some considerations about redacting addresses on MLab, and they were talking about replacing part of the host address with a hash of the host address. So it wasn't creating a new column, but it was replacing some of the bits. And it quickly discovered that all of those were subject to enumeration attacks. And it wasn't very hard to reverse engineer information about the hash just by being able, the fact that you can enumerate all IPv4 addresses pretty quickly. And if you know anything about the key or anything, there's a bunch of attacks there. Because of the way our data is used, we do want to have the anonymation and the annotation include routing information and things like AS information. And that turns out to leak enough bits where there are even potential ways of doing cryptographic attacks. The next slide is completely rewritten since the last time anybody saw this. I've come to realize I knew that there were some interesting behaviors in IPv6 addresses. It turns out, and I did not know this, it is now standard for applications, IPv6 applications and operating systems to support fast rollover of the low bits of the IPv6 address. That in fact, IPv6 addresses for many uses may not be good identifiers at all. And the problem is, for people who are using this configuration, for people who configure it in a paranoid way, there are no 0 bits in the middle of the address, and you can't tell where the ISP's part of the address ends and where the user's part of the randomized address begins. And so it's so we have some interesting challenges here, and we actually don't understand all the consequences. So there are lots of ways of understanding repeated tests from single IPs, but there's actually some forensics there. One of the things I didn't mention about the diagram, the graph I showed up front about there being 10% of IP addresses generate 60% of our data. I don't actually know the statistic, but it was also true that about 60% of our traffic was through tunnels. And the heavy hitters, the first 100 or so addresses on that list, are all through a tunnel with an overhead of 222 bytes. I don't know what tunnel uses 222 bytes, but I'm real suspicious that we are being used either to provide chaff for a VPN service, that is background traffic to obscure what's going on, or we're being used to DDoS a VPN service. And figuring out what's going on in that graph is actually going to require understanding, knowing for sure what those IP addresses are and where they map to. Yes, if anybody knows about a tunnel type that's got 222 bytes of overhead, please let me know, especially that one. I've also mentioned a whole bunch of things about shared IP addresses, and actually IPv6 should be added to this. Well, excuse me, shared is sort of the other way around, but yeah. We don't know how to even today we don't know today how to do things like count hosted IP addresses. We can do it a little bit with fingerprinting. We don't know how to automatically detect carrier grade NAT. We've got some ideas, but we haven't actually done the work. Anyhow, there's a bunch of experiments involving things like shared IP addresses. We really want to know about the IP addresses. The IPv6 one actually comes under here. A lot of ISPs, in fact, in Deutsche Telekom and maybe all ISPs in Germany, change your IP address every 24 hours. And so beacons, repeated tests from Germany aren't easily identified. You can see people who run more than one test a day, but other than that. And my home IP address typically changes a couple times a year. And it depends entirely what your ISP is doing. So there's a whole bunch of interesting questions there and so on. Another thing that we use IP addresses for is a bunch of measurement experiments back at MLab. And the basic idea here is most of a large fraction of the repeated tests are a piece of user gear infrastructure. Often home routers do this, that do an MLab test a couple times a day, 24 hours a day, 365 days a year for years. And if you pick one IP address and look at it, it turns out to be a wonderful measurement of how we have changed over time. And so we calibrate ourselves. One of the ways that we calibrate ourselves is by looking at repeated tests in our own data, user tests. And very often you can infer, oh, this is, this person's on 100 megabit Ethernet, or is on Comcast with 100 megabit local Ethernet bottleneck. And you'll see step changes in the performance when they upgrade their gear. You see step changes in performance sometimes, but hopefully not when we change something on our platform. You see notches from noise, from traffic, and notches from noise in the measurement. And you can measure all these parameters. And this is actually a super powerful tool that we use for understanding and calibrating our instrument. Another case that comes up periodically is we have had a couple of collaborations with different people who manage a specific set of clients, and they know about the clients. They want to do measurements from the clients. I have a box running in my house, which is a curated set of clients. And it's really nice to be able to pick it out of the data by IP address. Actually, it's got a client identifier, and it's the fastest way for me to find the history of my IP address, because I can go look up the client identifier. But there are a bunch of experiments that sort where changing the way we anonymize the data, or anonymizing IP addresses, might affect the ability to find the data. So, questions and conversation. I opened the floor. I saw there were some chats that went by. I didn't get a chance to read them.
I see a hand from Jake. Go for it.
Yeah, hi. Did you consider any explicit consent? Like,
So that's what the AS, oh, for the users?
yeah. So like you could allow the users to configure a client. So the last stuff you're talking about with MLab, uh, and researchers who have specific clients where privacy is not a concern for their particular case, et cetera, right?
Usually what's happened in those cases is the client fleet isn't ours, it belongs to the researcher, and the researchers have often had separate usage agreements that often included specific opt-in. So
Right,
we
right.
provide the measurement and they need to be able to find their data in our platform, but the outside researcher then does it. There have been a number of experiments that put a wrapper around our system with a completely separate privacy policy for the wrapper that essentially obscured the fact that they were using us to do the measurements because the wrapper had the specific consent. There have been some metropolitan scale, I think only metropolitan scale measurements where people opt in to save their HTML5 location. And then we get performance data by essentially by street address to the extent that we get much data and actually performance data and ISP data by street address. And so this is a way of validating like the FCC, what is it, 477 report.
Yeah, so my
Data
question
points.
is, so my question is basically like, would you consider having different tiers where, with explicit consent, you have actually extra data that might include unredacted IP addresses when someone said,
So
I would prefer this test to run with unredacted IP addresses or something.
I hadn't thought about doing it from the client side, but the problem is the language that is going to be a challenge to change is collect and archive. And if we collect and archive it for anybody, we can't change that. You can put you can imagine writing a bunch of caveats on it, but the fact is if some of the data is collected and archived for anybody, then that's what the privacy statement has to say.
Right, but I thought that
There's
was like like this can still match GDPR with the right caveats on it, right? It's like
right.
only when the
We do
user is
match
explicitly.
we do match GDPR actually under some of the exception clauses.
Okay.
And well, that's the issue. We
Yeah,
are compliant with the GDPR.
obviously, yeah. I mean, I support this effort. It's good that you're working out the privacy considerations and redacting identifiable information. That's fantastic. I'm just saying, I think there are use cases where someone might prefer to release things and maybe when it's their own test.
Yeah.
Supporting this might be an option, and then it gives you
the vast majority of our traffic comes from users who have.
Well, yeah, it's all going to be driven by defaults mostly, right?
Right, and have no interest. And in fact, the language that appears if you do search on Google, how fast is my internet, and you get a test box, the language that appears there is quite scary.
Sure.
And that's actually the language that I would like to change, make that less scary.
I'm curious if anyone has any thoughts about how any of the redacting techniques would affect their research.
Yes, it would be especially useful to hear from people who have that sort of problem.
I just unmuted myself. I know that David Clark and I have, he could articulate it better than I, but we have some types of research that we do that is dependent on our being able to get unredacted IP addresses. Fortunately, he couldn't be here today. Otherwise, he could give a more complete account. But I know he is, he and, I share his concern. The raw data is always better than redacted or fuzzed data, or simply because you're not really dealing with the real thing. You're dealing with something you can't identify. You can't identify the different components, the different characteristics, et cetera, et cetera.
If I can add a comment here, we're one of your users that has a full wrapper around it. And for all the privacy information that we collect it independently of your platform. So if you pulled the IP address, we'd never notice. Our collections occurred before we launch into your testing.
So do you keep the test UUID or do you just keep the result from the client?
We do not get the UUID. We do keep the result from the client. Essentially, the geocoding methodology that we use is definitely covered by personal privacy information. So we have to have our own legal wrapped around that. It's much more stringent than what you have.
Yes. And your own consent, user consent.
Yeah, and it varies by state, so it's no fun.
Varies by state in the US.
Yes, it does. I don't know what the rest of the world looks like, but I'm sure it's not pretty.
So were there questions in the chat?
I think Sasha had
The
a theory about the tunnel.
Yeah, the tunnel does. I don't believe it's uTorrent, but so I haven't even looked up. I haven't even done reverse lookups in some of the IP addresses. I have done reverse lookups. I only recently put in an automatic detect thing that automatically detects stuff that looks like it's tunneled, and because it sort of just, it's one of the things I hadn't gotten to. It occasionally said, "Oh, the MSS on that connection is funny. It must be tunneled." But I added it as a column in one of the internal data sets that I get, and I was astonished to realize how much stuff was tunneled. And reverse lookup, we wanted to know for sure if this was actually Tor, and so we ran some tests where we saved the UIDs through Tor, and Tor does not look like it's tunneled. They do a NAT at the end, and they completely hide stuff. So
I'm curious, Sasha, how are you finding this information? Because I've been poking around while we've been talking for the 222 bits overhead, and I've been finding all kinds of strange things.
yeah, it's an odd size.
I found one thing. This may mean something to you. It certainly doesn't to me. It's something at LoRaWAN. Found some articles, and then something about there was something around Bitcoin.
I think this data goes back further than that, actually.
Yeah.
I don't know.
On the topic of the user agreements, I'm curious if anyone here, I don't know, what are thoughts around that? Do people have any objections? Would they find it more difficult to use the data if a user agreement was involved, basically just stating what you cannot do with the data that would affect user privacy? What we've heard from some folks is that it's actually quite normal, and that it's people expect to have to sign something like that to access data like ours. But yeah, that's one thing we wanted to know is like how does that work for our users to have to sign something like that to access the data?
I'm a user and I'd be fine with it. In fact, it's pretty normal. I mean, a lot of US government data sources have those kinds of requirements.
Yeah. Yeah, in its original vision, the data would be published such that you could even access it anonymously. And this was because we wanted to encourage ISPs to look at each other through our lens.
The dilemma is that anybody could do it.
Right, right. But we wanted ISPs to discover ways in which they might improve themselves and discover ways in which their neighbors are doing better. It was an explicit intent early on. I see a hand up. Bob Balance.
Yeah. Two things. I'm still a little confused in the switch, what happens with the current geolocation data. But speaking to user agreements, I'm increasingly finding use cases where some portion of the data is open, like you would like, and other pieces of the data need to be behind usage agreements or other authorization mechanisms. And what you want to do there, what I would like to see, is to make sure that you have a good discovery process so we can find out what's open and what needs what level of authentication or authorization to get to. Because I keep seeing this as I'm working with data models and data layers. We just have to accommodate for private data, public data, and semi-public data all over the map. And the usage agreement is one way to do that.
Matt, do you want to speak more to what would happen with the current geolocation?
Yeah, so the geolocation has to be done early, and because of the way the copyright is written on the geolocation data, we're no longer allowed to archive the geolocation data set, which is what we were doing before. And so what we do is collect annotations. We do the annotation sort of contemporary with the test, and then archive the specific data that we need to label the tests, and the annotations come through separately. And that pipeline could be extended in lots of ways, like I mentioned in the slides. I didn't actually say it, but the annotation process was designed with this problem in mind, even though we didn't have a solution. So, did I miss something in the question?
The other part was just Bob saying that the data sharing agreement could also be a way to get at this, if I understood correctly.
Oh, another thing, as a result of this exercise of preparing these slides, we discovered that BigQuery has a capability of doing per column ACLs. And that's actually the right way to deal with this, because we could have a single tables that contain all of the data, and then you need to have special permission to access certain columns. We have no idea how hard it is to manage. We have no idea if that technique fits into our current facilities. That would be actually kind of nice. The other thing is the raw data probably would have a separate permission on it. The raw data is so large that it's difficult to use it for searching. So if you want to say, okay, if you want to look for a particular IP address, if you have hash data and you want to look for a particular IP address, the amount of data that you have to do in order to find it is likely to be prohibitive. And so just the sheer size of the raw data protects it some. But an fairly easy thing to do is put a different ACL on the raw data, and you need to look at it. We do want to make the raw data completely available to some people because it's an important part of the science for people to be able to replicate our processing. We want to make sure that the processing can be done.
Well, the science and the policy end of it as well. So if people are using our data to make public policy decisions, we want them to be able to reproduce it.
Yes, it's
I think you sparked an investigation on the looking at what title that is. But also, Stefani, would you mind speaking to your comment more about the data sharing agreement?
Yeah, sorry, here I am. What I meant, sorry, I had the laptop closed. What I meant is that I would love to see, of course, directly the changes in the data set. If a contract will be a contract, I mean, ask directly the users which kind of data could be shared, or the app that had the test in it directly. I would like to see how is the data set affected. So of course, if a users don't provide the data, they say to do not share it. I'd like to see how much in length will be affected the data set that is currently shared. And in case for one question that question answer that asked if the users could eventually share more data. On the research point of view, I was thinking if that the data set in that case would be too scarce to infer any results, or could be a good test to see which kind of research could be done there. So it's a test in both cases. And yeah, I don't know if any of you have some hypotheses on how much could be affected, or if people usually, if there is a bunch of data that can be shared, usually just shared all of them. Of course, it's a question at the top of the other discussion that was held before. Thank you.
Yeah. Yeah, I think people would by default not opt in. And the reason we provide the measurement is because we want the data. Yeah.
In behavioral economics, opting out is the opt-out choice is actually deemed more preferable, apropos of nothing or something.
Yeah.
Matt, do you see this latest question? Has there been any discussion around browser measurements from Apple devices which use the new private relay scheme?
I actually wasn't aware of the private relay scheme. I'm in frequent contact actually with the Apple developers, and we pass each other suggestions. So I will ask. I wasn't aware of the private relay scheme. I'm not an Apple user. There is evidence that there are people who use our service to test tunnels in legitimate ways, I get some occasionally see a connection that looks really weird, and I only recently, because I put in this code to notice tunnels, realized that the reason the connection looked really weird is because it was actually two concatenated paths that were very different, and it didn't make sense. It was basically it looked like LTE data that was coming from Comcast. Well, it was LTE data through a tunnel coming through from Comcast. So, so there's some stuff like that we don't understand. There's lots and lots of mysteries in the data.
Yeah, I think that's a good point from Glenn too about HTML5. It's not a perfect solution. And I think that's why a lot of surveys, including I think maybe yours, Glenn, ask the user to drag and drop, their actual location or where they see themselves on the map, and then also submit their address as well.
Yes, and HTML5 location is limited by how well the phone does locating and whether or not certain algorithms are available. Yeah, most of the time it's very, very accurate. But
that's actually something we could do a whole other town hall on. I think, to be clear, if we were to try and collect geolocation information, it would be within a hashed format and not just archived in our database. But in terms of usability for broadband mapping, it's something we've thought about. Because currently, as Glenn knows, that's something that our integrators do themselves and store separately, which could continue. But you could imagine our public database being annotated as well in a private way. there was a question about UNI's PII data and not including their, well, it's not a question, a statement. They remove potentially PII data and do not include IP addresses in their measurements. And Matt, I'm sure you've talked with Simone about how UNI does it. Have you considered?
So there was a time when UNI was thinking of partnering with MLab, and we were actually looking at that time. It was one of the times we looked at doing strong anonymization on the platform. They wanted to use MLab for doing their measurements, and then they realized that they couldn't risk it. If their data was fingerprintable in MLab, it would leak the location, potentially leak the locations of their users. And so they moved to a completely different solution. But that was actually where the connection to Simone came from, because he was at one of those meetings before we realized it.
But have we considered what, I don't know about how they handle it, but have we considered that?
I actually haven't asked what they do, and I could.
Yeah, I think that would be
so.
That'd be useful. Thanks for bringing it up.
So any other questions about the main technical conversation? I actually have one more topic, and what I did to Lai, which she hasn't seen yet, is I held my last slide until the end of the conversation.
Sneaky.
Because the last slide is going to be controversial. What is PII? And the reason I ask is because the first paragraph of the definitions defines a person. And I don't believe we actually have a person. IP addresses without a person are not PII. And the question is whether or not there's any way our data might be used to indirectly identify a person. And I believe the answer to that is also no, but I don't know for sure. And I wish that our official statement was something like this. And it will be fun to do that. Timur.
Yes, hi, Matt. So I put a link in the chat. The IP addresses, we could discuss whether it's a fair interpretation, but they are considered to be, I guess the term is in GDPR is personal data. So they are considered to be an identifier that can be used to identify individuals. This being said, you have legitimate basis for collecting the information.
Right, but there's no other personal part of it. It's like the only thing that we have as personal is the IP address. And
well,
we're very careful about things like whether or not we get too much fingerprint from the clients and stuff like that, right? It's the only identifier that we have. There's nothing to join with except for information.
Right.
The issue is that traditionally the word in there that gets you in trouble, oops, I gotta move is where it says indirectly identified. And what that means is you need to be able to assert that your data cannot be joined with external data, which then de-anonymizes somebody. Well, if I join it with somebody who's got a person and an IP address, they already have all of the information. I'm not adding any information to it. And I don't know of any non-IP address, non-person, which could be joined with this to find a person.
If I can add a concept onto that, looking at this from California law, which is the most stringent in the United States, the law basically requires that if you collect personal information, the individual about whom it has been collected has the right to have their data removed from your database.
GDPR also says that.
How can you do that from an IP address?
It's actually quite easy, and it actually bears on this point. What happens is we get a letter saying, please remove my data. And we say, we have no record of what your IP address is. I know you said it was blah, but you can't prove it and we can't prove it. We need a certified notice from your ISP that this was the IP address that you were using. And nobody has ever done that.
So we're heading up on time, Timur. Did you have any last thoughts? Okay, great.
No, that's fine.
Okay, thank you everyone for joining. Like I said, this has been recorded and we'll post this for further feedback. If you have any follow-up thoughts, please let us know. I think the tunnel conversation will continue. So I'll end the formal session now. If you want to hang out, please do. But I'll stop recording now and send you on your way if you need to go. Thanks for joining. And if you came to this one, you'll get an invite to the next ones.